Okay, and we are recording. Let me go ahead and share my screen, share, and pull up our notes. So we are now going through 6.4, multiplying polynomials. And so our objectives are to multiply two polynomials, multiply binomials, square binomials, multiply the sum and difference of two terms, and multiply three or more polynomials, and evaluate polynomial functions. So how many times will Ms. Hogenkamp say polynomial in this video? The answer is probably a lot. So first up, we have for multiplying two polynomials, and there are a lot of special cases when we are multiplying two polynomials. So we are going to go over all of those special cases in this kind of like one broad stroke. And so first off, we have when we are multiplying monomials. When we are multiplying monomials, we want to group our like bases. Group our like bases and then apply the product rule for exponents. So we did a bunch of examples of these types of problems in the warm-up. So that was like when we have something along the lines of 2x cubed times 5x to the 6th. So our like bases are first going to be the numbers, which we have 2 times 5. Then our first variable, which is going to be x, we have x cubed times x to the 6th. And that's actually it. So we don't have another variable. We know that 2 times 5 is equal to 10. And if we're multiplying exponential expressions, we're going to add our exponents and get 10x to the 9th. So there's number A, or letter A. And then letter B, I want you guys to go ahead and try to work out on your own, but that should equal -7xy to the 15th z to the 9th. And so if you have questions about how to get that, please feel free to bring those questions to class. And that being said, we're going to move on to multiplying two polynomials. To multiply any two polynomials, use the distributive property and multiply each term of one polynomial by each term of the other polynomial, then combine like terms. So that's probably like a what? Weird sentence. But I think that it will become obvious as we do some examples. So special case here is when we're multiplying two binomials. So bi is 2, right? So that's when we have something plus something else, and that makes up our polynomial. So when we have two of those multiplied together, so two things of 2, there's 4 total terms, then we're going to use FOIL. And you've probably learned about this, first, outside, inside, last. And I'm going to show you now how it works. So when we have a binomial times a binomial, like we have an A, okay? So in A, we have binomial times binomial. B is a different thing. B is just a binomial times a polynomial. But in A, we have x plus 3 times 2x plus 5. And what FOIL helps us remember is how we multiply binomial times binomial. And what they mean is we want to first multiply the first terms. So that's x times 2x first. Then we want to multiply our outside terms, okay? So our outside terms is going to be this x and this 5. So plus x times 5. Next, we have inside. Our inside terms are this 3 and this 2x. So plus 3 times 2x. And then last, we have our last terms, which is going to be plus 3 times 5. Okay, so now we can figure out this multiplication. X times 2x is going to give us 2x squared plus 5x plus 6x plus 15. And then last, we want to combine our like terms, which are these two middle guys. So we're going to get 2x squared plus 11x plus 15. Box that guy off, and that is going to be our final answer. So again, special case number 1 is multiplying binomials, and we use the FOIL method. In example B here, we are multiplying a binomial times a polynomial. And so again, we can't FOIL because it's not a binomial times a binomial, but we still want to apply the same idea, where we're multiplying each term in the first polynomial by everything else in the second, right? So we have 2x minus 3 times 5x squared minus 6x plus 7, okay? So first we want to multiply our first term by everything in our second polynomial, right? So we're going to have 2x times 5x squared plus 2x times negative 6x plus 2x times 7, okay? And now we want to take our negative 3 and multiply our -3 by everything in the second polynomial. So now we're going to have -3 times 5x squared plus -3 times -6x plus -3 times 7. Okay? And now we can do all of that multiplication out. So 2x times 5x squared is going to give us 10x cubed plus 2x times -6x is going to give us -12x squared plus 2x times 7 is going to give us plus 14x. -3 times 5x squared is going to give us minus 15x squared plus 18x minus 21. And so now we can see that we've multiplied each thing in our first polynomial by everything else in our second one, okay? And so I like to draw those little like rainbow lines to help me keep track of everything. And now we can combine like terms. We see we have an x squared here, an x squared there, and a 14x and a 14x. And then our final answer is going to be sorry, I got really distracted there. Our final answer is going to be 10x cubed minus 27 x squared plus 32x minus 21. So it's a little more hands-on than FOILing, but as long as you are making sure that, again, you multiply each part of your first polynomial by every part in your second one, then you will be good to go. All right, and now this brings us to another special case, squaring binomials. So the square of a binomial, so that's when we have the same binomial. So a plus b quantity squared, that would be if like we had x plus 3 quantity squared. And we know that we could rewrite this out as x plus 3 times x plus 3. And so there's kind of a general form for when we have something in the form of a plus b quantity squared or a plus b or a minus b quantity squared, and that is a plus b quantity squared is going to equal a squared plus 2ab plus b squared, and a minus b quantity squared is going to equal a squared minus 2ab plus b squared. And it's okay if you forget these because you can ultimately just FOIL everything out and get your same answer. But it's kind of nice to have an example or to know that and have some sort of example for it. So for example, if we had x plus 5 quantity squared, we know that a plus b quantity squared equals a squared plus 2ab plus b squared. So we see how we have a and b here. So x plus 5 quantity squared is going to equal a squared, while our a in this case is x, plus 2ab, so plus 2 times a, which is x, plus b, which is 5, plus b squared, which is 5, so plus 5 squared. So then we're going to get x squared plus 10x plus 25. And so it's kind of a simpler way to evaluate, sort of, if you remember it, but you could literally also just rewrite x plus 5 times x plus 5 and then do first, outer, inside, last, and you'll get the same answer. So this is kind of convenient, but if you forget, you can always fall back on trusty FOIL. And then we have another special case here. This is the product of the sum and difference of two terms, and this is a plus b times a minus b will equal a squared plus or minus b squared. And I almost hesitated to put this one in there because a lot of times people kind of make a mistake when they are multiplying binomials or something and they think that it's just going to equal a squared plus b squared. But it only equals a squared minus b squared when we have a plus b times a minus b, okay? So this is when we would have something like x plus 3 times x minus 3. Okay, so then we have a plus b times a minus b, which is going to equal a squared minus b squared. Our a in this case is x, so x squared minus our b in this case is 3, so it's going to be minus 3 squared, which is going to equal x squared minus 9. So again, kind of useful to know, but again, if you forget, you could just FOIL it out and get the same answer. So part 2 is multiplying 3 or more polynomials. And this really just comes down to working slowly through each piece and making sure you're being very careful of your algebra, right? So if we have x plus 3 or x minus 3 times x plus 3 times x squared minus 9, the first thing that I want to do is take care of my first two. So I'm going to multiply by my first two, and then I'm going to multiply by the third one. And then if there's a fourth one, I would multiply the product of the first three times the fourth, and etc. So you just start with your first two, multiply those together, and then keep multiplying if there's more layers. So I'm going to start with my first two, which is x plus 3 times x minus 3, which I actually just did. And I got x squared minus 9 as my final answer there. So I got x squared minus 9 for my answer there. And then my next term I'm going to add on is times x squared minus 9. So that's kind of a funny thing there. So we'd have x squared minus 9 times x squared minus 9. And in this case, we have the one where we had a minus b quantity squared. And we know that a minus b quantity squared is equal to a squared minus 2ab. Let me scroll up a little, plus b squared, because we can rewrite x squared minus 9 times x squared minus 9 as x squared minus 9 quantity squared. So we do have a minus b quantity squared. A is x squared, b is 9. Okay, and so now we know it's going to equal a squared. So that's going to be, I'm going to switch colors so we can see it. X squared squared minus 2 times a times b plus b squared, which is going to be 9 squared. So then we get x squared squared, power to a power is going to be equal x to the fourth minus 18x squared plus 81. And that is my final answer there. So generally, sometimes you can use those fancy special cases that we learned, sometimes you can't. But either way, when you're multiplying 3 or more polynomials, you want to start with the first two and then keep adding layers. And then last but not least, we have evaluating polynomial functions. So if we have this polynomial, f of x equals x squared plus 5x minus 2, we want to find f of 2. Easy. All we do is replace 2 every time we see x, right? So we're going to have 2 squared plus 5 times 2 minus 2. So we're going to have 4 plus 10 minus 2, which is going to equal 12. A different sort of case for these is if we were asked to evaluate something like f of a plus 1. But this follows the exact same idea, right? So every time we see an x, now we're just going to have an a plus 1. So we'll have a plus 1 quantity squared plus 5 times a plus 1 minus 2. Okay, so a plus 1 quantity squared is the same thing as when we had a plus b quantity squared, which equals a squared plus 2ab plus b squared. In this case, our a is a and our b is 1. So this is going to equal a squared plus 2 times a times 1 plus 1 squared. So we're going to get a squared plus 2a plus 1. Okay. And then for over here, we're just going to distribute. So a plus 1 quantity squared was a squared plus 2a plus 1 plus 5a plus 5 minus 2. And now combine like terms. A squared doesn't have any like terms. We have 2a plus 5a is going to give us plus 7a. And then we have 5 plus 1, which is 6, minus 2 is 4. So we get a squared plus 7a plus 4. So that's kind of just a different twist on evaluating polynomials, but still pretty straightforward. And that is all for 6.4. Get excited for 6.5. We get to, you know, some really fun stuff. Factoring, everyone's favorite F word in math. Woohoo. Okay, anyway, this was kind of a scattered video. But if you have any questions, again, tutorial is always open. Email, I'm on constantly. Just gonna stop sharing this and end this video now. Yeah.